The problem on test 1 that gave me the most trouble was problem number 3, part C. The question is, determine the position of the block 0.2 seconds later. Apply the momentum principle 2 times in steps of 0.1 seconds. Your answer should be a vector and an SI units. So, to do this, you're going to use iterative steps. You're going to find the force, the net force for each step, then the final momentum, then the final position. And these are all vectors. So for the first time step, we're going to start by finding F net, which we actually found in part B. And my answer to part B was the x component was 0, the y component was 0.472, and the z component was also 0, and this is in newtons. To find the P final, we're going to use the equation P final equals P initial plus F net delta T. And this is an application of the momentum principle. We know that P initial is a 0, has 0 in all 3 places. It's a 0 vector because the initial velocity is 0 and momentum is mass times velocity. So if the velocity is 0, then the initial momentum will be 0. The F net we found up here. And the time step is what they gave us, which was 0.1 seconds. So this will give us a final momentum of 0 in the x component, 0.0472 in the y component, and 0 in the z component. And this is newtons seconds. And you know that because the force is in newtons and you're multiplying it by seconds. That's newtons seconds. Okay, so now we're going to find the position. So we're going to start with, now we're going to find the position, which is R final equals R initial plus V average delta T. This is also an application of the momentum principle. You'll notice that it's asking for V average, which we don't have up here before, but we do have the final momentum. So you can solve for the final moment. You can solve for the V average from the final momentum. And in our case, there is not a constant force in this equation because it's a spring, so the force is going to change with time. So we're going to use the final velocity for the V average instead of the average, like the mean that you take in math of final plus initial divided by 2. So we're going to use V final instead of V average. So we're going to solve for that first, or V final. And this is the momentum equals mass times the velocity. So velocity is momentum divided by mass. And if we're solving for the final velocity, then we want the final momentum divided by mass. Here's our final momentum. We're going to divide this by the mass, which the problem gave us, which is 0.06 kilograms. Make sure you have your units right there. Okay, so I'm going to erase this part and just solve for V average. Okay, and then you're going to get your V average is equal to the vector 0 in the x component, 0.787 is the y component, and 0 is also the z component, and your units for velocity are meters per second. Okay, so now as we said before, we're going to use the equation r final equals r initial plus v average delta t. And we have all these values, so we just plug them in. Our initial position is given to us. Well, the y component of it was given to us. We assumed that the x component is 0. The y component was given to us, and it's 0.2. And the z component was not given to us, so we also assume it's 0. Plus this v average, which is right up there, times our time step of 0.1 seconds, like we said before. So our r final, when we solve it, is 0 is the x component, 0.2787 is our y component, 0 is our z component, and this is in meters. Okay, so now we have our r final. But this is only for 0.1 seconds, so we have to do this process over again with another 0.1 second time step, and we're going to have to recalculate the force, the final momentum, the v average, and the r final. So the things that you need to keep in mind are the p final, which is going to become the p initial of the next time step, and the r final, which is going to become the r initial in the other time step. So I'm going to erase this, and we're going to do the next time step. Okay, so again, we have to start by solving for the F net. And we haven't already solved for this because there wasn't another part B. So we know that the F net, just like as it was solved in part B, is F of the spring plus the force of gravity. Now in part B we solved for the force of gravity. We know it's the same as before because force of gravity doesn't change, or it'll change slightly, but we're going to assume that it stays the same, and that's negative 0.224 newtons. And the force of the spring, you can easily calculate that. It's just the spring constant, which is negative the spring constant, which is 8.7 times L minus LO. So L, we know LO is 0.28 because they gave that to us, but L, you might be like, what is that number? That is the final position that we found, the y component of the final position that we found before. So that number was, just if you didn't write it down, 0.2787. Okay, so when you solve for this force, the force of this spring, you're going to get 0.0109. So the F net is just these two added together. Remember, F spring is positive, F of gravity is negative. So when you add these two numbers together, you are going to get an F net of negative 0.213 newtons. Okay, so now again, we're going to go back to our momentum principle. P final equals P initial plus F net delta T. So our P initial was our P final in the last problem, which we know if you didn't write it down, it's 0 in the x component, 0.0472, 0 in the z component. Plus our F net, which is right up here, and if we write that as a vector, it's 0, negative 0.213, 0, times our time of 0.1 seconds. It's the same time step. Okay, so when we have all this, we find that our final momentum is 0 in the x component. Oops. Negative 0.213 in our y component. No. Sorry, guys. I was looking at the wrong thing. Okay. 0.02599 in the y component, 0 in the z component. Newtons. Okay. Again, our force is not constant, so we can just use the V final for V average. So our V average is just the P final divided by mass, which is the same as it was before. So 0.0025990 newtons divided by 0.06 kilograms. Okay, so now, and this is in vector form, 0.433, 0 meters per second. That's our V average. Okay, and then our final step is another application of the momentum principle, just like we did before. R final equals R initial plus V average delta t. So our R initial is our R final from the last step, which if you remember, it's 0.02787, 0 plus 0.433, 0 times 0.1 seconds. So our R final is, I'm going to do all the math, 0.322, 0 meters, because distance is in meters. So that is our final answer. I know that's a lot of work, and it'd be a lot easier if you could just program a computer to it, but on a paper test, you can't do that. So, thank you for watching.